What if everything we thought we knew about climate change was only part of the story? What if the fingerprints of humanity weren't the only ones found on the planet's fevered surface? And what if nature itself and forces far beyond our atmosphere were also quietly rewriting Earth's climate? For decades, the dominant narrative has been simple. Human activity, especially the burning of fossil fuels, is the primary culprit behind global warming. It's a conclusion supported by the overwhelming consensus of scientists and institutions worldwide. Carbon dioxide, methane, nitrous oxide, greenhouse gases released through industry, deforestation, and agriculture trap heat in the atmosphere and lead to rising global temperatures. The evidence is visible. Glaciers receding, oceans warming, species migrating, wildfires raging. Yet in recent years, new voices, some scientific, others skeptical, have asked whether this picture is too one-dimensional. Could natural cycles, solar variability, volcanic activity, or oceanic oscillations play a greater role than we admit? Are humans truly the main cause or just the most visible trigger of a much deeper planetary rhythm? To explore that question, we have to step back in time. Earth's climate has never been static. It has swung between extremes, ice ages and warm interglacials, long before the first factory smokestack appeared. The last ice age ended about 12,000 years ago, giving rise to the stable Holocene epoch, a period of relatively mild temperatures that allowed agriculture, civilization, and everything we know as modern life to flourish. But even within this period of calm, there have been dramatic fluctuations. The medieval warm period, roughly between 950 and 1250 AD, saw temperatures comparable to or even warmer than today's in parts of Europe and the North Atlantic. It was followed by the Little Ice Age, a cooler era lasting until the mid-19th century, when frost fairs were held on the frozen River Thames and glaciers advanced in the Alps. These shifts occurred centuries before industrialization. Clearly, Earth's climate can and does change naturally. The question is, how much of today's change falls within that natural variability, and how much is something new? One of the most significant natural drivers of climate is the sun. Its energy output, though relatively stable, fluctuates slightly over time due to solar cycles. Every 11 years, the sun's magnetic activity peaks, producing more sunspots and solar flares, which can influence the amount of energy Earth receives. Some scientists have pointed to periods of low solar activity, like the Maunder minimum between 1645 and 1715, as correlating with cooler temperatures on Earth. Others note that increased solar activity aligns with warming trends. Yet modern satellite data suggest that solar output alone cannot account for the rapid warming observed since the late 20th century. The sun's variability contributes, yes, but by perhaps only 10% of the total effect. Still, the interplay between solar cycles and Earth's climate is complex, and some researchers believe subtle amplifying mechanisms, such as changes in cloud cover or cosmic ray interactions, could magnify its impact. Then there's the deep breath of the oceans. The planet's vast water bodies act as both a heat sink and a conveyor belt, redistributing warmth through currents like the Gulf Stream and the Pacific's El Niño and La Niña systems. These oscillations can drastically alter weather patterns, shifting rainfall, drought, and temperature distributions across continents. During strong El Niño years, for instance, global average temperatures spike as the Pacific releases stored heat into the atmosphere. When La Niña takes over, temperatures dip. These cycles operate on timescales of years to decades, and some scientists argue that longer oceanic rhythms, like the Pacific Decadal Oscillation, PDO, or the Atlantic Multi-Decadal Oscillation, AMO, may explain portions of the warming and cooling trends seen over the past century. Ocean patterns are powerful, but they don't negate the influence of greenhouse gases. Instead, they modulate how that influence manifests. Still, distinguishing the natural pulse of the oceans from human impact is one of the greatest challenges in climate science. Volcanic activity is another crucial factor. When volcanoes erupt, they inject enormous amounts of aerosols, ash, and sulfur dioxide into the atmosphere, temporarily cooling the planet by reflecting sunlight away. The 1991 eruption of Mount Pinatubo in the Philippines, for example, lowered global temperatures by about 0.6 degrees Celsius for nearly 2 years. On geological timescales, massive volcanic events known as flood basalts have even triggered mass extinctions and long-term climate shifts. But the opposite can also occur. Volcanic CO2 emissions contribute to warming over millions of years. Still, current volcanic output of CO2 is estimated to be about 1% of human emissions annually. So while volcanoes are dramatic players in the climate story, they cannot explain the sustained rapid rise in temperatures observed since the 1950s. And that brings us back to humanity. Industrialization unleashed a force unlike any the planet had seen before. Coal, oil and gas, the ancient sunlight stored in Earth's crust, were burned to fuel growth, prosperity and population expansion. Atmospheric CO2 levels, stable at around 280 parts per million for thousands of years, soared past 420 ppm in just 2 centuries. This rise correlates precisely with industrial output, energy use and global temperature increases. Ice core samples from Antarctica reveal that never in the past 800,000 years has CO2 risen so fast. The greenhouse effect is not theory, it's physics. CO2 absorbs infrared radiation, trapping heat that would otherwise escape into space. Methane and nitrous oxide do the same, though at smaller concentrations but greater potency. Without these gases, Earth would be a frozen world. With too much, it becomes a pressure cooker. The balance is delicate, and humans have tipped it. However, to say humans are the only cause oversimplifies an intricate equation. Climate is the product of multiple feedback loops: ice albedo, cloud formation, vegetation changes, ocean absorption, that interact in unpredictable ways. For instance, as ice melts, darker ocean water absorbs more heat, accelerating warming. As permafrost thaws, methane trapped for millennia escapes, adding fuel to the fire. Deforestation not only reduces carbon absorption, but also alters regional rainfall and temperature. These feedbacks amplify initial disturbances, whether natural or human-made. What makes today's situation unique is the speed. Natural climate changes typically unfold over thousands of years. Ours is happening in mere decades. Still, skepticism persists. Some argue that climate models overstate warming or fail to account for natural variability. Others question the reliability of long-term temperature records, citing adjustments or measurement biases. But the overwhelming body of evidence, satellite data, ocean heat content, melting glaciers, sea level rise, points to a planet in rapid transition. Even conservative analyses by NASA, NOAA, and the IPCC confirm that over 90% of observed warming since the mid-20th century is attributable to human activity. The signal of anthropogenic influence is now unmistakable. Yet, acknowledging that doesn't mean ignoring nature's role. Understanding both natural and human drivers is essential for prediction and adaptation. For instance, solar minima could temporarily offset warming, while volcanic eruptions could create short-term cooling. But these are fluctuations atop a rising baseline. The planet's energy balance continues to skew toward heat retention, a trajectory unlikely to reverse without drastic emission reductions. Interestingly, not all human impacts are intentional. Aerosol pollution from factories and ships has actually cooled the planet slightly by reflecting sunlight, masking part of the warming. As air quality improves, that masking fades, revealing hidden heat. This paradox means cleaner air, ironically, could accelerate short-term warming before long-term benefits emerge. It's a stark reminder of how intertwined our actions are with Earth's systems. Another layer of complexity arises from the political and economic dimensions of climate change. For some, questioning human responsibility is less about science and more about ideology. Powerful industries have historically funded misinformation campaigns to protect profits. On the other hand, some critics of mainstream climate activism warn that fear-based narratives can lead to extreme policies that harm economies or deepen inequality. Between these poles lies the truth. Climate change is real, human activity is a major driver, but adaptation and mitigation must be balanced with realistic strategies. Simplistic blame games, either it's all humans or it's all natural, do justice to neither science nor humanity. The deeper philosophical question is why we seek a single culprit at all. The Earth is not separate from us, we are part of its living system. The Industrial Revolution was not an alien invasion, it was humanity expressing its creativity, often blindly. The climate crisis, then, is not just an environmental issue, but a mirror reflecting our relationship with power, consumption, and foresight. To heal the planet, we must first understand the mindset that created the imbalance. This requires not only renewable technologies, but also renewed values, humility, responsibility, and cooperation across nations. In this sense, the question, are humans the main cause of climate change, becomes less about assigning guilt and more about recognizing agency. Yes, natural cycles exist. Yes, solar and oceanic dynamics matter. But today, humans are the most influential variable in Earth's climate equation. Not because we are omnipotent, but because our collective actions now shape processes once governed solely by nature. We have become a geologic force, a species that can alter the composition of the atmosphere, redirect rivers, and reshape coastlines. This power demands stewardship, not denial. Imagine standing in front of a thermostat that controls not a room, but an entire planet. That's the position humanity finds itself in today. The knob was turned slowly at first, then faster, until the system began to tremble. We can debate whether natural fluctuations would have warmed Earth anyway, but we cannot deny that our hand is on the dial. The data tell a consistent story. The 10 hottest years in recorded history have all occurred since 2010. Glaciers are retreating at unprecedented rates. Coral reefs are bleaching. Extreme weather, floods, heat waves, droughts, is intensifying. These aren't political talking points. They are the lived experience of billions. Still, hope remains. If human activity can destabilize the climate, human innovation can also restore it. Renewable energy technologies, solar, wind, hydro, geothermal, are expanding faster than ever. Electric vehicles are redefining transportation. Reforestation and soil regeneration projects are drawing carbon back from the air. But the clock is ticking, and every year of delay compounds the challenge. The real question isn't whether humans caused climate change, it's whether we're willing to take responsibility for it. Because the alternative, denial or paralysis, leads to a future no one wants. Rising seas swallowing cities, displacement of hundreds of millions, food insecurity spreading as crops fail, conflict over dwindling resources. These aren't distant scenarios, they're the logical endpoint of inaction. And yet, amidst the fear, there is opportunity to rebuild economies on sustainable foundations, to innovate our way toward equilibrium, to prove that intelligence means more than cleverness, it means wisdom. So, are humans truly the main culprit? Perhaps the better answer is, we are both the cause and the cure. Nature will continue its cycles, but our choices now determine whether those cycles become catastrophes. The planet doesn't need saving, it will endure. It's humanity's place within it that hangs in the balance. The story of climate change is not about villains and victims, it's about awakening. We are the first generation to fully understand our impact, and possibly the last with the power to change it. Whether we act out of fear, faith, or love for what we stand to lose, the outcome will define the next chapter of Earth's history. If this message resonates with you, if you believe awareness must lead to action, then join us. Subscribe to Crisis Lens, like this video, and share it with others. Together we can face the truth, look through the lens clearly, and help shape a future where balance between humanity and the planet is no longer a dream, but a reality.